Now we are going to see regarding fuels. So fuels. A fuel is a combustible substance containing carbon as the main constituent, which on proper burning gives large amount of heat that can be used economically for domestic and industrial purpose. During the process of combustion, the atoms of carbon, hydrogen combine with oxygen with simultaneous liberation of heat. The calorific value of a fuel mainly depends upon the two elements, that is carbon and hydrogen. So this can be understood by the two reactions given here. That is carbon combines with oxygen forming carbon dioxide with the liberation of 94 kilocalories of heat. And this hydrogen reacts with oxygen forming water with the liberation of 68.5 kilocalories of heat. So carbon compounds have been used in for many centuries as the heat of source of heat and energy. So the main source of fuel is coal and petroleum. These are the stored fuels available in Earth's crust and are generally called fossil fuels because they were formed from the fossilized remains of plants and animals under the action of pressure and temperature for millions of years. Now we'll see how fuels are classified. Fuels can be classified into two types. One is primary fuel and another one is secondary fuel. Primary fuels are the fuels which occur in nature as such. Example for this one is coal, petroleum and natural gas. Secondary fuels. Secondary fuels are derived from primary fuels. Example coke, gasoline, coal gas, etc. So these primary and secondary fuels can be further divided into solid fuels, liquid fuels and gaseous fuels. Uh, the unit of fuel is the efficiency of a fuel is given by its calorific value. Calorific value is the total quantity of heat liberated when a unit mass of the fuel is burned completely. Unit of heat. The unit of heat, there are so many units available for heat. One is calorie, which is the amount of heat required to raise the temperature of 1 gram of water through 1 degree centigrade. Kilocalorie, that is equal to 1000 calories. It may be defined as the quantity of heat required to raise the temperature of 1 kilogram of water through 1 degree centigrade. That is 1 kilocalorie is equal to 1000 calorie. British thermal unit. It is defined as the quantity of heat required to raise the temperature of 1 pound of water through 1 degree Fahrenheit. This is the English system unit. Now we'll see what is HCV and LCV. HCV means higher or gross calorific value. Usually all fuels will contain some amount of hydrogen, and when the calorific value of hydrogen containing fuel is determined experimentally, the hydrogen is converted into steam. If the products of combustion are condensed to the room temperature, the latent heat of condensation of steam also gets included in the measured heat, which is then called higher or gross calorific value. So gross or higher calorific value is the total amount of heat produced when unit mass of the fuel have been burned completely and the products of combustion have been cooled to room temperature. Then lower or net calorific value. In actual use of any fuel, the water vapor and moisture are not condensed and escape as such along with hot combustion gases. Hence, a lesser amount of heat is available. So, net or lower calorific value is the net heat produced when unit mass of the fuel is burned completely and the products are permitted to escape. Net calorific value is equal to gross calorific value minus latent heat of condensation of water vapor produced, R, which is equal to GCV minus mass of hydrogen per unit weight of the fuel burnt into 9 into latent heat of condensation of water. So we can use Dulong's formula for calculating the calorific values. That is HCV is equal to 1 by 100 into 1 by 100 into 8080 percentage of carbon plus 34,500 into percentage of hydrogen minus percentage of oxygen divided by 8 plus 2240 into percentage of sulfur kilocalorie per kg. So this CHO and S represent the percentage of carbon, hydrogen, oxygen and sulfur in the fuel. So LCV is given by HCV minus 9 by H divided by 100 into 587 kilocalorie per kg. So this is based on the fact that 1 part of hydrogen by mass gives 9 parts of H2O and latent heat of steam is 587 kilocalorie per kg. Now we will see about solid fuel. That is, the important solid fuel is coal. It is a natural fuel. That is a primary fuel. Coal is a fossil fuel that is produced from large accumulation of vegetable debris due to partial decay and alteration by the action of heat and pressure over millions of years. Coal is a highly carbonaceous matter that has been formed as a result of alteration of vegetable matter under certain favorable conditions. It is chiefly composed of carbon, hydrogen, nitrogen and oxygen besides non-combustible inorganic matter. Coal can be classified on the basis of this rank. Rank is defined as the degree or extent of maturation and is therefore a qualitative measure of carbon contents. Peat, lignite and sub-bituminous coals are referred as low rank coals, while bituminous coals and anthracites are classified as high rank. In European terminology, lignite and sub-bituminous coals are called soft coals, while bituminous and anthracite coals are termed as hard coals. In North American terminology, the coal series can be written as wood, peat, lignite, bituminous coal and anthracite. In order to assess the quality of coal, there are two types of analysis are made. One is proximate analysis, another one is ultimate analysis. Proximate analysis include the determination of moisture, volatile matter, ash and fixed carbon. This gives quick and valuable information regarding commercial classification and determination of suitability for particular industrial use. Ultimate analysis include the determination of carbon, hydrogen, nitrogen, sulfur and oxygen in coal. Since it is used for the determination of element present in the coal, it is also called elemental analysis. This analysis gives exact results and are useful for calculating the calorific value of coal using Dulong's formula. Now we'll see what is proximate analysis. First analysis in proximate analysis is moisture content. For this purpose, we are taking 1 gram of finely powdered air dried coal sample that is in a crucible. The crucible is placed inside an electric hot air oven which is maintained at 105 degree to 110 degrees Celsius. The crucible is allowed to remain in an oven for 1 hour and then it is taken out and it is cooled using a desiccator and it is weighed. Loss in weight is reported as moisture on percentage basis. Percentage of moisture is equal to loss in weight of coal divided by weight of coal taken into 100. Then we have to analyze volatile matter. Then the derived sample of coal that is left in the crucible after moisture content analysis is then covered with the lid and it is placed in an electric furnace, that is muffle furnace, which is maintained at 925 degrees Celsius. The crucible is taken out of the oven after 7 minutes of heating. The crucible is cooled first in air, then inside a desiccator and weighed again. Loss in weight is reported as volatile matter on percentage basis. Percentage of volatile matter is equal to loss in weight due to removal of volatile matter divided by weight of coal sample taken into 100. Then ash content determination. For this determination, the residual coal in the crucible is then heated without lid in a muffle furnace at 700 plus or minus 50 degrees Celsius for half an hour. The crucible is taken out, cooled first in air and then in desiccator and then weighed. Heating, cooling and weighing is repeated till a constant weight is obtained. The residue is reported as ash on percentage basis. Percentage of ash equal to weight of ash left divided by weight of coal taken into 100. Then Finally, fixed carbon can be determined by using the formula percentage of fixed carbon equal to 100 minus percentage of moisture plus volatile plus ash content. Now we will see what is the importance of this proximate analysis. Proximate analysis provides some of the valuable informations in assessing the quality of coal. First, this moisture content will reveal the lowers the effective calorific value of coal. Moreover, it quenches the fire in the furnace, hence lesser the moisture content, better the quality of coal as a fuel. However, presence of moisture up to 10% produces a uniform fuel bed and less of fly ash. And the significance of volatile matter. A high volatile matter containing coal burns with a long flame, high smoke, and has low calorific value. Hence, lesser the volatile matter, better the rank of the coal. Higher volatile content in coal is undesirable. A high volatile matter content means that high proportion of fuel will be distilled and burned as a gas or vapor. The volatile matter present in the coal may be combustible gases such as methane, hydrogen, carbon monoxide and other hydrocarbons, or non-combustible gases like CO2 and N2. Volatile matter content is of special significance in coal coal gas manufacture, and in carbonization plants, particularly when byproduct recovery is the main object. Thus, high volatile matter containing coal do not cake well, whereas medium volatile matter content coals are capable of yielding hard and strong coke on carbonization. Then ash. Ash is a useless non-combustible matter which reduces the calorific value of coal. Moreover, ash causes the hindrance to the flow of air and heat, thereby lowering the temperature. Also, it often causes trouble during firing by forming clinkers, which block the interspaces of grate. This in turn causes obstruction to air supply, thereby the burning of coal becomes irregular. Hence, lower the ash content, better the quality of coal. The presence of ash also increases transporting, handling, and storage costs. The presence of ash also causes early wear of furnace walls, burning of apparatus, and feeding mechanism. Then, significance of fixed carbon. Higher the percentage of fixed carbon, greater is its calorific value and better the quality of coal. Greater the percentage of fixed carbon, smaller is the percentage of volatile matter. This also represents the quantity of carbon that can be burned by a primary current of air drawn through the hot bed of a fuel. Now we will see what is the significance of ultimate analysis. Carbon and hydrogen content significance. Greater the percentage of carbon and hydrogen, better is the quality in coal and calorific value. However, hydrogen is mostly associated with the volatile matter and hence it affects the use to which the coal is put. Also, higher percentage of carbon in coal reduces the size of combustion chamber required. The amount of carbon, the major combustible constituent of coal, depends on the type of coal and its percentage increases with rank from lignite to anthracite. Thus, percentage of carbon forms the basis of classification of coal. Nitrogen has no calorific value and hence its presence in coal is undesirable. Thus, a good quality coal should have very little hydrogen content. Now we will see the significance of sulfur in coal. Sulfur, although contributes to the heating value of coal, yet on combustion produces acids which have harmful effects of corroding the equipments and also cause atmospheric pollution. Sulfur is usually present to the extent of 0.5 to 3% and derived from ores like iron pyrite, gypsum, etc., mines along with the coal. Presence of sulfur is highly undesirable in coal to be used for making coke for iron industry since it is transferred to the iron metal and badly affects the quality and properties of steel. Moreover, oxides of sulfur pollute the atmosphere and leads to corrosion. Then oxygen content decreases the calorific value of coal. High oxygen content coal are characterized by high inherent moisture, low calorific value and low coking power. Moreover, oxygen is in combined form with hydrogen in coal and thus hydrogen available for combustion is lesser than actual one. An increase in 1% oxygen content decreases the calorific value by about 1.7% and hence oxygen is undesirable. Thus, a good quality coal should have low percentage of oxygen. These are the two analyses which are done for ranking the coal, that is proximate analysis and ultimate analysis. Thank you.